So let's do a calculation. How much energy is required to heat 10 grams of ice at 0 degrees Celsius to liquid water at 50 degrees Celsius? Okay. So the first thing I do in a calculation like this is I sketch it. So we know that we are heating curve, and I just draw it real small, and I just put X's where we start and stop. Okay, so we have 10 grams of ice at 0 degrees Celsius. So I'm someplace on this flat curve, but it tells me I have ice. So because I have ice, that means I have to have a solid, which means on this flat curve, here's my solids, here's my liquid. If it's all ice, I'm right here at the start of the melting, right in that spot. Okay? I want to warm it up to liquid water at 50 degrees Celsius. So it means I had to go across this to warm it up, and then I gotta, to melt it, and then I gotta warm it up to 50 degrees Celsius. So I have one Q value, two Q values to actually solve for in this process. Okay? This Q value is a flat line, so I need to use the heat of fusion times my moles. Heat of fusion I can look up because we're dealing with water. We're warming it up, so this heat of fusion will stay positive. This Q value is a temperature change, so we'll use MCAT to solve for this one. Okay. When we're all done solving for this Q and this Q, we need to add the two together. Okay. One thing to make a note of, when you solve for Q in this equation, your answer is going to be in joules. When you solve for Q in this equation, your answer is going to be in kilojoules. You must convert before you add them together. So they're both in the same unit of measure. Okay? So, go ahead and do the calculation and see how you do, and then we'll come back in a second and show you the answer key. Okay, so here's our answer key now. Our first step, we had to convert from grams to moles because our equation required moles. We plugged in the molar heat value for water times the moles, got 3.34 kilojoules. In our second equation, we had to use MCAT. We had our grams, the specific heat capacity for water, and our change in temperature. We got 2,090 joules, and then I converted those to kilojoules, and then so I could add the two together. Now I could have converted this one to joules. It's just, it means the same thing. I don't care which one you do. Okay. Now last step is add them together. Okay. So I take the 3.34 plus the 2.09, adding those two together, and I get 5.43 kilojoules of energy. Okay. This number should be positive because we're warming it up and we're absorbing energy. All right. Now, go ahead and try this one. This one will take you through all 5 steps across the heating curve, and it starts you on high and works you down low. So you should have negative values on this process. Okay. Go ahead and try this one, and then I'll post up the answer key in a minute. Now I didn't show all the work with these because we're just repeating the same pattern. So we're using MCAT for the ones that change temperature, heats of molar heats for the ones that don't change temperature, and your 5 different Q values are given here, and then if you add them all up, you get negative 78.5 kilojoules for this process. Okay. If you need additional help with this, please come find me, and we can do that for you guys. Okay, we're going to stop the video here, in this segment here, and we will move on to chemical potential, energy, and that kind of stuff in our next segment. Thank you.